Hello and welcome. This is a lesson on the remainder theorem, introduction to chapter 2. The remainder theorem is used to do exactly that, find the remainder when you are dividing. Let's take a look at a question you've done before where we are asked to take 22 and find out how many times it divides into a number like 753. When you're looking at long division questions, because the divisor is a two-digit number, you want to look at a two-digit number of your dividend. And the question we ask ourselves is how many times does 22 divide into 75? And we see that the most that it can, without going over, is 3. 3 multiplied by 22 is 66. And recall, in long division, you are always subtracting. And 75 minus 66 gives us 9. We have to carry down the 3 and repeat this process until we run out of digits. And repeat, how many times does 22 divide into 93? And the answer is 4. 4 times 22 is 88 with a remainder of 5. Because we're out of numbers, we're finished. And so we can say 22 divides into 753 34 times with a remainder of 5. Let's take this same approach and apply it to polynomials. Let's take a binomial like x plus 2 and divide it into a trinomial x squared plus 5x plus 7. Now the same process occurs, we're just dealing with letters. We do have a binomial here, but really all we're concerned about is the first term of the binomial. And we are looking at the first term of the dividend. And what we want to do is think x times what is equal to x squared. The reason we think this way is we want to rid ourselves of each of the terms in the dividend till we have none left, similar to what we did in our long division question. The answer to that is x. So that means that we are multiplying our first x by the multiplier x to give us x squared. Now distributive property tells us we have to multiply the x by the 2, and so we need to carry that down. Notice that we have two terms and we're subtracting two terms. That's decided by what we're dividing. When we do subtraction, the x squareds cancel out, so that becomes 0x squared, or really we just don't write anything in, and we are subtracting, so it is going to be 5x subtract a positive 2x, which is 3x. The next step is just like we did in the first question, is we bring down the next term. In this case, it is a plus 7. Once again, we think, what do we need x to multiply to be in order for the product to be 3x? And the answer is 3. Because it's a positive 3, we write down a positive 3. And then we distribute the 3 into the x plus 2. 3x plus 6. We do have a remainder again. This time it is a remainder of 1. We're now complete. We've used up all of our numbers in our dividend. The answer is really the quotient, and we are using x plus 2 as our divisor. One last thing, notice where we put the first multiplier of x, which was this one. We put it after or on top of the second term. This is just good form. We don't need anything above the x squared term. This keeps us lined up in columns and rows. We can take this approach and look at many different examples. Let's take a look at one more. This time we are taking x minus 1, which is our divisor, and we are dividing it into our dividend, which in this case is actually a cubic. Now, I don't really like how this is written. We always write our powers in descending order, so the first thing I'm going to do when I set up my division question is I'm going to rearrange this, and I'm going to place the exponents in descending order. We are now ready to continue the same way we did before. So the question is, what do we need to multiply x by, because that's the first term, in order to get 2x cubed. And there's lots of different ways you can think of this. The term that we need to multiply x by to get 2x cubed, in this case, is 2x squared. The 2x squared goes above the second term, and then we distribute it. We always should get the same terms lined up to start, and then we need to multiply 2x squared by negative 1. This is subtract, but we do have to be careful a little bit with our brackets here. So the 2x squared minus 2x cubed minus 2x cubed disappears. Negative 3x squared minus a negative 2x squared is a positive. So that simplifies to become negative x squared. We continue by bringing down the next term and repeat. X multiplied by what is going to be equal to negative x squared, and that's negative x. We write the negative x above and continue. Again, always wanting these terms to be the same. Negative x times negative 1 is positive x, and we don't forget to subtract. First two terms cancel. 8x minus a positive x is 7x, and we bring down the next term. So long division is very much repeating over and over. We like it because as soon as we have the routine in the first, we just keep repeating it. This is subtract, so negative 12 minus a negative 7 is really adding 7, so we end up with negative 5. So our final answer is x minus 1 divides into 2x cubed minus 3x squared plus 8x minus 12, 2x squared minus x plus 7, there's our quotient, with a remainder of negative 5. Now sometimes we want to write this in different forms, and the textbooks ask us to write it in something called the quotient form. And what that looks like is we state the dividend over the divisor. To remember what that was, minus 3x squared plus 8x minus 12 all over x minus 1, and that is equal to, I'm just going to put it below here, and I'm going to write the quotient, 2x squared minus x plus 7. And then what we would do if they wanted in quotient form is we would put a plus sign, we'd put whatever the remainder was, in this case it was negative 5, over the divisor.